All right, we are in Unit 2, Section 2. We're working with exponent rules. Today we're looking at the quotient rule. Our objective is the student will be able to simplify expressions using the product rule, zero rule, quotient rule, and the negative exponent rule. Today we're looking at the quotient rule, which states if a is a non-zero real number and m are integers, then a to the power of m divided by a to the power of n equals a to the m minus n power. All that's saying is when you divide like bases, you subtract the exponents. In this case, a's are the bases. Since these are the same, they're like bases, that means we can take the exponents and subtract them. We have some examples we're going to be going over today. We'll start off with example 1. We're using the quotient rule to simplify. Example 1 says x to the power of 7 divided by x to the power of 4. So what we're going to do is realize that these two things are the same. So this is going to be our base. Our base is x. Our exponents are 7 and 4, and we're going to subtract them. This is going to become x to the power of 3. I'm not solving for x. I'm not looking for its value. I'm just simplifying it as best I can. Same deal with example 2. I have 5 to the power of 8 divided by 5 to the power of 2. So I know that my bases are the same. So that's going to be my base. Pardon me. It's going to be 5. And my exponents are 8 and 2. I'm going to subtract my exponents, and I have 5 to the power of 6. Now, 5 to the power of 6 is something that you're actually going to have to process to write out. That's going to be an actual number here. We have 15,625. The only reason this answer gave me an actual number is because I didn't have a variable. I had a number raised to a power. Let's go ahead and take a look at example 3. Example 3, I have 20x to the power of 6 divided by 4x to the power of 5. We have a couple things going on here. I have 20 over 4. I'm going to have to address that. And then I have x to the power of 6 over x to the power of 5. So we have two pieces here. Well, I know that 20 divided by 4 is going to be 5. And then I have x to the power of 6 over x to the power of 5. So I know my base for my letter is going to be x. I have a 6 and a 5, and I'm going to subtract them. This is going to be 5x to the first power. You don't have to write down an exponent of 1. You can leave it out, so this is just equal to 5x. Example 4, we have three pieces here. I have 12 over 14. We're going to start off there. 12 divided by 14. I can't divide 12 by 14, but what I can do is reduce it. They're both even numbers, so I can divide each number by 2. 12 divided by 2 is 6, and 14 divided by 2 is 7. So that's going to reduce. In the middle, I have y to the power of 10 divided by y to the power of 8. So I know my base there will be y. My exponents are 10 and 8. And then lastly, I have some z's. I have z to the power of 7 divided by z to the power of 6. So I know my base is going to be a z. My exponents are 7 and 6. So what I have here is 6 over 7 times y to the power of 2 times z to the first power. Now what you are able to do here is put the y squared and the z to the first power in the numerator of that fraction. So you can have 6y squared times z divided by 7. Okay, we're going to take a look at our next set of examples. I have example 5, 3p to the 9th power divided by 15p to the negative 8. I'm going to start off here. I have 3 over 15. Both of those numbers are divisible by 3. So I'm going to have 1 over 5. And then I have p to the 9th over p to the negative 8. So my base here is p. I have 9 and negative 8, and I have to subtract those two numbers. So 9 minus negative 8, that's going to become positive. So I'm going to have 1 over 5 times p to the 9 plus 8 power, which is going to be 1 over 5 times p to the 17th. Again, what you can do is put p in the numerator. So you have p to the 17th over 5. Okay, we have example 6. Example 6 is a little different. Up in the numerator, you have 2 times x squared times x cubed over 8x to the power of 4. If you look in the numerator, right here, this is a product rule, which we talked about the other day. The product rule states that when you have like bases, you add your exponents. So for right now, what we have is 2 times my base is x, and my exponents are 2 and 3. I'm going to add those exponents because when you multiply like bases, you add the exponents. My denominator is still going to be 8x to the power of 4. This is going to simplify up top, and it's going to become 2x to the power of 5 over 8x to the power of 4. Now from here, we treat it like a normal quotient rule. I have, hit the wrong button. I have 2 over 8. I can reduce that to 1 over 4. And then I have x to the 5th over x to the 4th. This is going to be x to the 5 minus 4 power. And that's going to become 1 over 4 times x to the 1st. And I'm going to put x in the numerator. So it's going to be x over 4. Okay, example 7. I have 2 times x to the 3rd times 3x to the power of 5. I have two numbers in the numerator. I have 2 and 3. So I'm going to go ahead and put those together, 2 times 3. And then I also have x to the 3rd times x to the 5th. So I'm going to have a base of x in the numerator, and my exponents are 3 and 5. Again, because I'm multiplying like bases, I'm going to add my exponents. The denominator has not changed for us. It is still 9x. So up top, we have 6x to the power of 8 over 9x. Now it's just like any other quotient rule problem. I'm going to take the 6 over 9 and I'm going to reduce. This is going to become 2 over 3. And then I have x to the power of 8 over x. My base is x. My exponents are 8 and 1. So I have 2 over 3 times x to the power of 7. I'm going to move x to the power of 7 into the numerator. So I have 2x to the power of 7 over 3. Our very last example. This is pretty much the same as any of our other examples, except up top I have 3 letters, in the bottom I have 3 letters. They might not be in the same order in the top and bottom, but that's fine. We're just going to match our letters and our numbers. To start us off, I have 12 over 2. And I have r to the 7th over r. I have p squared over p to the 8th. And then I have L to the power of 4 over L. Okay, cool. 2 over 12, or 12 over 2 is going to reduce to be 6. I have r to the 7th over r to the 1st. So r to the 7 minus 1 power. P to the 2nd over p to the 8th, so 2 minus 8. And then I have L to the 4 minus 1 power. Okay, let's go ahead and simplify. 6r to the power of 6, p to the power of negative 6, and L to the power of 3. All right, that was the quotient rule for exponents.